Let's go through LeetCode 1888 minimal number of flips to make the binary string alternating. So give us a string as it is a binary string, and we can perform two types of operations. Type 1 is remove the character at the start of the string as an append to the end of the string. And type 2 is pick any character and flip the value, that is 0 to 1 and 1 to 0. There is a minimal number of type 2 operation you need to perform such that it becomes alternating. Let's observe the type 1 operation, right? So type 1 operation, it doesn't count how many count operation value. So we are trying to find a type 2 operation minimal counts. Type 1, that means it has some features. For example, if this string S, it is a even number of lengths. So this is one of the feature. If it is even number of lengths, no matter how many characters we move from the front to the end, right? It will not change the type 2's operation counts, because the things that we'll see if it is even, right? So this 0, 2, 4, those kind of indexes, they are coming from with pairs, right? So even move to the end. So this will be n minus 2, right? So if move to the end, right? So we'll see that this one, the 1 will become 0, and 0 will be n minus 1. So it's still this one, this is coming to be 1, right? So this is n minus 1. 0 become n minus 1. It's still coming like this as pairs, right? So that means for the even length, we can ignore type 1 operation, right? But the thing is that for the odd number of operation, right? The number type 1 counts. But the type 1, the things there are another several features we want to observe is that we can manipulate type 1 multiple times. And no matter what kind of order, type 1 with type 2, we'll find it will be the same result. We move one part from the front to the end, right? So that is, you can, for example, move 0 to the end, and then do operation type 2, and then move 1 to the end, then do type 2, then index 2 to the end, to then do type 2. It's the same effect as you do for 0, 1, 2, the 3 index from front to end for type 2, right? So that means for the even number, what we want is that we just want to find an optimal solution, which we cut from the prefix and move it to the end, which will have a minimal flips, right? So this become a circle. You see, it's like a circle, right? To handle the circle problem, the one of the best way is that we can have this string to double its size as string plus string, right? Then what we do is that we find a fixed size window which has a window size k, right? K is this string's size, and the 2s is or one string length, right? And we have this kind of window of sliding in a 2s string, trying to find the smallest flip size, right? So let's say so this will be, for example, this will be S. This is another S, right? Then we use a fixed size window that is with a string length that is K, right? So 2S, let's say that is N. So we have this K slide from the left to right, right? Until in the end it is like this, right? So we want to find the minimal flip in this fixed size window. So how many flips in these windows? So let's consider a special case for a specific fixed size window, right? So every time there is a number from the right to enter this window, and there is an left index moving out of the window. So the flip, there are two types of strings in this window. One is 1 0 1 0 1 0. Another is 0 1 0 1 0 1. Right? So what we want is that let's say this is R1, this is R2. And always say this is R1, this is R2, right? So that means that we just want to say its index. And so for every I, if this is an index, this is an odd number, right? Odd number entering. Um, mm, every time this is an odd number entering, we trying to see if this character is 0 or not, or 1, right? So let's say if it is 1, right? We need to change it from the right end, this is changed to 0, right? So that we can consider from the right side 0, 1, and this is 1, 0, right? So we want to have it like in a reverse order, 0, 1, 0, 1, 0, 1, right? Until to the end. And for this one is 1 0 1 0, right? So it doesn't to be 1, right? We have doesn't to be 0. We have R1 should do a flip, should plus equal to 1. Otherwise, we have R2 should plus equal to 1, right? So on the left side, we also we have an index move outside of this kind of window, right? So that is we should I minus K, right? Trying to see for this one if it is odd or even, right? So it is odd. Um, we we have same parity with this one, right? So that if we want this one to be 1, right, or to be 0, right, but it is 1, we should minus equal to the differences, right? So so for every window we have an R1 and R2. That is to flip as 0 1 0 1 from the right side. How many what it counts, and also the 1 0 1 0 from the right side what counts, right? We just want to find the minimum of this. So so that is the minimal flip for this kind of window. But this means that we want to know global minimum, so that we need to have a K size just a string length size sliding window, uh, just slide from a 2s string to see what is globally the minimal value. So knowing this, we can write code. So the things that we know if s dot length, right? If it is an even number, actually, we don't need to do the type 1 operation, right? So what we do, we can write something, for example, um, for int I equals to 0, I smaller than um, s dot length I plus plus, right? So also we can have int R1 equals 0, R2 equals 0, right? So what we do is that in char c equals s dot char at I minus 0, right? So we'll say if I divide 2 equals 0, right? Then we're going to have R1 should plus equal to C and R2 plus equal to 1 minus C. And else R1 equals 1 minus C and R plus equal to R2 plus equal to C, right? So just return max dot mean R1 and R2. So we'll see if it is an even number of lengths, right? Actually, we don't need to care about the type 1 operation. Um, so, but for odd, we need to care about because the type will depend um, how many index from the left side move in that which originally that is an even index moved to the odd index, right? So we have to do the sliding window way, right? So, but the thing is that actually, for even number of the lengths, we don't need to write this corner case for it for it, right? Because slide window can apply for the general case, both the even length or odd length. So so we can comment this. So let's write a general case. So no matter it is even or odd, right? So we are going to have s equals s plus s, and we're going to have int n equals s dot length, and that has k is the original s length, so it will be s n divided by 2, right? And have result equals integer dot max value because we want to find our minimal value, right? So we also have R1 equals 0 and R2 equals 0. Then what we do is that for int I equals 0, I smaller than n, I plus plus. So we're going to have C equals s dot char at I minus 0, right? So we'll say if this kind of I and 1 equals 0, right? So this is the same as if I mod 2, right? If I mod 2 equals 0. So we get its parity, right? So we'll say if so we'll say R1 should plus equal to C and R2 plus equal to 1 minus C, right? Else we are going to have R1 plus equal to 1 minus C and R2 plus equal to C. So this is the entering character, right? And we'll say if I is greater equal to K, so there is some kind of character moving out of our fixed size window, right? So we can have int j equals I minus k. Okay. And we are going to have another index integer will be s dot char at j minus 0, right? So we'll see if j and 1 equals 0, so we're going to have R1 minus equal to D, and R2 minus equal to 1 minus D, right? And else we'll have R1 minus equal to 1 minus D, and R2 minus equal to D. So the things that if we have enough size of window, so if I greater equal to k minus 1, then we're going to have results equals mass dot mean results, and mass dot mean R1 and R2, right? So in the end, just return results. So this will be the code. For this kind of length equals it is even, it also fits the general case about the sliding window. It will be O n time complexity with constant space complexity. Let's also write a Python code for this. So we're going to have S equals S plus S, and n equals the length of S. So we're going to have K equals n divided by 2. And result equals float IF, right? Then what we do is have R1, R2 equals 0, 0. Then what we do is for I in range n. So we're going to have C equals ORD SI minus ORD 0. So we'll say if this I and 1 equals 0, so this is the same as I mod 2 equals 0, but use ampersand and the operation will be faster. We'll have R1 plus equal to C, R2 plus equal to 1 minus C, and else we're going to have R1 plus equal to 1 minus C, and R2 plus equal to C, right? And we're going to say if I is greater equal to K, right? So there is some character moving from the left side. So we'll have J equals I minus K. And we'll say D equals or D S J minus or D 0. So I'll say if J and 1 equals 0, right? So we'll say R1 should minus equal to D, and R2 should minus equal to 1 minus D. And else I have R1 minus equal to 1 minus D, and R2 minus equal to D, right? So we'll say if we have enough size of window, so we'll say if I is greater equal to K minus 1, then we're going to have results equals mean results R1, R2. In the end, just a return result.